Section 7.2, Part 1, the standard normal distribution. Lesson objectives: find the area under the standard normal curve. The standard normal distribution looks like this. It has a mean of 0 and a standard deviation of 1. And if you remember from our last video, these are what we call the points of inflection. Here's the properties of the standard normal curve. Number 1, it's symmetric about its mean, mu equals 0, and it has a standard deviation of 1. The mean, median, and mode all equal 0. The highest point occurs at z equals 0. It has inflection points at mu minus sigma, negative 1, and mu plus sigma, positive 1. The area under the curve is 1. The area under the curve to the right of mu equals 0 equals the area under the curve to the left of mu equals 0, which is equal to 1/2. As the value of z increases, the graph approaches, but it never equals 0. As the value of z decreases, the graph approaches, but never equals 0. And the empirical rule also works. 68% of the area under the normal curve is going to be between z equals negative 1 and z equals 1. Approximately 95% of the area under the curve is going to be between z equals negative 2 and z equals positive 2. And approximately 99.7% of the area under the curve is going to be between z equals negative 3 and z equal to a positive 3. Now what we're going to learn in this video is actually finding the area under the curve, and it's even more precise than the empirical rule. Lesson objective number 1. Using Table 5. Table 5 is located in 3 places in your book, on pages A11 and A12. It's on the 2 pages of the back cover, and it's also on the formula card. Table 5 gives the area under the standard normal curve for values to the left of a specified z-score. So it's always going to give us area to the left. So as you're looking up these probabilities, the first thing, always draw the picture. The table gives the area or probability to the left of the calculated z-score. Calculate all z-scores to the thousandths place and then round them to the hundredths place, which is 2 decimal places. Use both the column component and the row component of the z-score to find area or probability values. The table entry at the conjunction of the column and row components is the desired left area or probability value. The left area or probability values for the calculated z-scores with values that are less than negative 3.49 are set equal to 0.0001. We're going to call that a default value. Left area or probability values for calculated z-scores that are greater than 3.49 are set equal to 0.9999, and that's going to be our second default value. This is what Table 5 looks like, and here's our z values. These are the row components, and the row components tell us the whole number and the first decimal place, and the columns tells us the second decimal place. The smallest value the table can give is negative 3.49, which is 0.0002. If we get a z-score smaller than a negative 3.49, we're going to use this default value 0.0001. So that's the area to the left of anything less than this z-score. The largest value in the z-score table will be 3.49, which is this value. So anything over a z-score of 3.49 we're going to set equal to 0.9999. So the area to the left of any value more than 3.49, we're going to use this default. Let's look at an example. Find the area under the standard normal curve to the left of z-score equal negative 0.38. So our first step is we want to draw a picture. From the picture we see that our answer should be less than 0.5. So we go to our table 5. First we get the row component, which is negative 0.3, and then we need to get our column component, which is 0.08. And where these intersect, that will be our answer. So the area to the left of z equals negative 0.38 is 0.3520. Let's look at another example. Find the area under the standard normal curve to the left of z equals 0.61. Positive 0.61 is above 0. So we can see just from our picture this answer should be more than 0.5, because again half the graph to the left of 0 is 1/2, and this is larger. So we go to table 5, we do 0.6, and then we do 0.01 for our column, and we see that the area to the left of this z is 0.7291. Now if we're trying to find the area to the right, we need to do 1 minus the area to the left. Let's look at an example. Find the area under the standard normal curve to the right of z equals 1.25. So first let's do our picture. We see that this area is less than 0.5. So our answer should be less than 0.5. So what we're going to do is we're going to look up this area to the left, because the table only gives us area to the left, and then we're going to do 1 minus that value. So we first look at our row component, 1.2, our column component, 0.05, and we see that the probability is 0.8944. Now because we're finding area to the right, we have to do 1 minus 0.8944, which gives us 0.1056, and that number agrees with our picture. Here's our next example. What if we're asked to find the probability in between two z's? So in this one we're looking between negative 1.02 and a z value of 2.94. First we draw our picture, and we see that this most likely is going to be larger than 0.5. So our first step is we're going to calculate the area corresponding to this value and the area corresponding to this z, and we're going to subtract the two. So for the first one, it's 0.1539. For the next z, 2.94, we get 0.9984, and then we take those two areas and we subtract them, and we end up with 0.8445. So these are our three examples. If we want to find the area to the left of a z-score, we just look it up in the table. If we want to find the area to the right of z-score, we look up the z-score in the table and we do 1 minus that area. And if we want to find area in between two z-scores, we look up the largest z-score, write that area down, look up the smallest z-score, write that area down, and subtract those two. Thanks for watching.